Greetings, children. Welcome back. Today we are talking about scale drawings. So we're on section 6.10. If you've got your books, page 218. So let's take a look. A scale drawing here, let's look at the definition. It says it's used to represent distance or size, since it's often impossible to draw the actual distance or size. So when we're talking about a scale drawing, we're talking about one of two things. Either an enlargement of something or a reduction of something. So let's think about what those two things would be. If we were talking about a reduction, right, then we can talk about a scale drawing. You've seen scale drawing reductions many, many times. In fact, you probably have something on your phone that uses a scale drawing reduction right now. It's called a map. So Google Maps, or just Maps if you're using Apple. And a map is a reduction because it's not the exact same size as what it represents. So we might have a map of the state of Kentucky. So here's Kentucky. This little piece right there too. So we might have a map of Kentucky, or that might be the Pizza Hut symbol. I'm not really sure. Not the best Kentucky I've ever drawn. But that would be a reduction, right? Because Kentucky's not actually that big. We could make it larger or smaller. Okay, maybe I should have drawn like Utah. That would have been easier. So there's a drawing of the state of Utah. Or is that Nevada? Oh, no, I don't know. So we have a scale drawing. That would be a reduction. But if we were trying to draw molecules, then that would be an enlargement, right? Here we have our nucleus of some atom, and then we have some other atoms that are connected to it, and we have a molecule. So that would be an enlargement, because we obviously couldn't draw small enough to draw an atom, so we have to use a scale drawing to represent what an atom would look like. Okay? So there's the two types of scale drawings. Now let's talk about how we use a scale drawing, or how we calculate things for scale drawings. If you take a look at example 6.10a, it says the scale drawing, or the scale for a scale drawing, is 1/2 an inch is equal to 5 feet. How long is a line segment if the length on the scale drawing is 3 inches? So what it's asking is, how do we represent something that's 3 inches long? What does it represent in the actual model if our scale is 1/2 an inch is 5 feet? So what we do is we set up a ratio, and then we make a proportion. So remember, a ratio is just a fraction that compares two things. And then a proportion is when we have two equal ratios. So for our ratios, we're always going to set them up the same way. The scale on the top, on both sides, and the actual amount on the bottom. Now these are going to have units, so it'll help you put the things in the right spots. So for example, this one says 1/2 an inch. So the scale here is in inches. And then that means this scale is also in inches. And then the actual amount for our first part is 5 feet. So this is in feet. So that means our actual amount over here is going to be in feet. And that's important when we're solving this proportion, because we need to know where the other parts go. So the other part says, how long is a line segment if the scale drawing of it is 3 inches? So it tells us 3 here. And this is the part we don't know, so we're going to use a variable, or an unknown term here, to plug in. So now we have our proportion. Now, if you recall, we saw proportions earlier in the year. It's been a bit since we've done it, but we'll go over several examples of how to do these. So to solve a proportion, you cross multiply. So let's just look at a really basic example first. let's say we have A over B equals C over D. Cross multiply, you do A times D is equal to B times C. So A times D is equal to B times C. So that's cross multiply. Top of one times bottom of the other equals the bottom of the first one times the top of the other. So we call that cross multiplication. And that's what we use to solve a proportion. So let's take a look and try that here. We usually do the one with x in it first, the cross multiplication. So let's do that. 1/2 times x is equal to 5 times 3. Okay? So then we can simplify that other side. 1/2 x equals 15. And then to finish solving this, there's two different ways to look at it. You can multiply by 2. That'll cancel the 1/2. Or think of it as dividing by 1/2. So x equals, and then we have 15 divided by 1/2. Remember, when you're dividing by a fraction, you're multiplying by the reciprocal of that fraction. Okay? So we have 15 times 2 over 1, or just 15 times 2. So that's equal to 30. All right, and our answer here, we need the units, so the answer is feet. So we have 30 feet. So now, let's make sure our answer makes sense. We had that 1/2 of an inch in our scale was 5 feet in the actual drawing, actual world here. So if we have a 3 inches for our scale, how many feet would we actually have? Would it represent 30 feet? So yeah, that makes sense, because this times 6 would give us this, so this times 6 would give us that. So 30 feet is our answer. So we're going to be working with things like that. Let's take a look at a few more examples. Remember, you set these up the same way. You set up a proportion. Sometimes your proportion is a little easier to solve. Sometimes they're a little bit more challenging, but you know how to do the math behind it. It's just multiplying, working with fractions or decimals. So let's try this next one. It says, for a scale drawing 3 inches in the scale is equal to 1 inch in the actual object. Okay, so we have our scale and actual. Now both of these are actually in inches. So 3 inches for this one is equal to 1 inch in the actual. So now we have to pay close attention to the words that are in there. So it says scale and actual again. Okay, it says what's the height of an actual object? So that's the part we don't know. If the scale drawing is 4.5 inches. So 4.5. Okay, so on these ones that have fractions, if the fractions are easily converted to decimals, like this one, then I would suggest converting it to a decimal, 4.5. That would make it a lot easier to work with. So here, we're going to cross multiply. 3 times x is equal to 4.5 times 1. Well, 4.5 times 1 is just 4.5. Now we're going to divide both sides by 3. And here you get x is equal to 1.5. So remember, everything here was in inches, so inches, 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 inches. So that means that our answer is also in inches. So our answer is 1.5 inches. You could have also done it as a fraction. It works the same way. You can change your answer back to a fraction if you'd like. So 1.5 inches. Okay, let's look at another example. So let's say that it gave us a map, and it told us that the scale on the map was 1/4 of an inch, so this is inches, is equal to 4 miles over 4, and this is in miles. So that means over here, for our scale, it's going to be in inches, and the actual's in miles. And then it tells us, it gives us a drawing. So this is on page 220. This is number 16 through 20. And it gives you a drawing with different cities that are separated. So, for example, it says like A, B, C, D, and you're supposed to measure those. So let's just say that we had the drawing here, and that this was 2 inches, and this other part was 1 inch. Okay, and it asks, how far is it from A to C? And we're assuming that we have to use the path that it gives us. So since we're using that path, that means we would have to add these parts up. Think of it as driving along a road. To get from A to C, you can't just skip B there. You have to go through B. So that means that this would be a total from A to C will be a total of 3 inches on our scale drawing. So 3 inches on the scale. We don't know what the actual is yet. And then we multiply. So 1/4 times x equals 3 times 4. So we get 1/4 x equals 12. And then, like I said earlier, there's 2 ways to think of it when you have fractions. You can multiply by the reciprocal of the fraction, which in this case would multiply both sides by 4/1. 4's cancel over here, you get x, and then 12 times 4 is 48. So that means that this distance from A to C, where it's 2 inches from A to B, 1 inch from B to C, total of 3 inches, would represent 48 miles. So you can see, working with maps, that's part of our exercises. We're also going to be working with shapes and making some scale drawings as well. So to make a scale drawing, let's say it gave you the scale and then it gave you an actual amount. So let's look at one like that. Let's say that it tells us that our scale let's say the scale, like it tells us here, is 1/8 of an inch, represents 1 foot. So 1/8 of an inch is equal to 1 foot. Remember, we set up the fraction the same on both sides. Scale over actual, scale over actual. Make sure our units are the same for both sides. Then it says how much would be represented if the actual, so if you were trying to make a scale drawing from an actual thing. So how much would be represented if we had 16 feet? So 16 feet. So that means we don't know the scale part, so we would try to figure it out. So notice there's a different piece missing. So here, this one's pretty straightforward. We have 1 times x equals 1/8 times 16. 1 times x is x. 1/8 times 16. Remember, you can just cancel these. We're just working with fractions. 1 times 2, and then 1 times 1, so it's equal to 2. And then let's look back. What are our units for our scale? Inches. So our answer is 2 inches. So if our scale is 1/8 of an inch is equal to 1 foot, and we measured something and it was 16 feet, then in our scale drawing it would be 2 inches. So keep that in mind. There's also a possibility that when you're making a model or a drawing, that it is the same size. If so, we call it a 1-to-1 ratio, and we say that it's the same, it's not an enlargement or a reduction. So think about it like this. A map is a reduction. It's usually a huge reduction because we couldn't have like 1 inch is equal to 1 foot. Right? If we had a map of Kentucky that was like that, it would be huge. So think if you had a map of Kentucky that was actually a 1-to-1 ratio, that it was actually the same as the scale. That would mean that if you unfolded your map, it would cover the entire state of Kentucky. So your neighbors would probably get pretty mad at you if you did that. Okay? So that's why I have to make the maps a little bit smaller. Alright, remember, if you have any questions, feel free to call, text, or message me. Thanks. We'll see you again tomorrow.